I'd like to talk to you about entities, which I hope will be more interesting to you than terms perhaps were. Entities and their attributes and types in databases. This is the second of 3 week 2 videos. So databases keep track of entities. So these are things in the real world that we want to store information about. And they can be physical objects or they can be events. Um, so entities have different kinds of durability, like a person persists. I guess you could say different kinds of persistence. A person persists and a book persists, but a sale or a meeting is kind of a transient thing. So it's an event. It can be a transaction. And usually entities are named as nouns or gerunds. Gerunds are verbs acting as nouns, usually ending in ing. For example, a person is an entity, a sale is an entity, and a meeting is an entity. And in the books table, which we looked at in the terms video, the entity described by the rows is a book. And there are no rows in the table that describe anything but a book. And the word entity is commonly used in 2 ways. It may mean the rows collectively, or it may be a synonym for entity instance, which is a row. So when we refer to a row as an entity, we really mean an entity instance, but I typically say entity when I'm talking about a row, and hope that it's just understood that it's really an entity instance. There are a lot of people who specialize in databases who are very concerned about the precision of the terminology, and it really depends on what you're doing as to whether the precision in the terminology is important or not. So entities have characteristics or attributes or fields or columns, and these may be nouns or adjectives. The attributes themselves might be entities. If so, they are probably described in a separate table. For example, a book might have an author, a genre, and a publication date. And the author, genre, and publication date are attributes of the book. And the author is an entity and might be described in a separate table. And the genre is an attribute, but it might also be an entity if there are other attributes of genres that we want to store. And the publication date is an attribute, but it's not an entity. We are probably not going to store a table of all publication dates. And every attribute of an entity is a specific data type. And no column can have 2 or more data types, although there is one exception to that rule, which I'll talk about later. Um, Specific implementations of databases accept different numbers and different storage classes of data types, and this can complicate matters quite a bit, and I'll explain now. So in SQLite, there are 5 storage classes, and the storage classes are null, which means that we don't have the data, integer, which is a whole number, and it can be positive or negative, by the way, real, which is a floating point number, text, and blob, which I'll explain what that is in a minute. Anyway, these are almost data types, but not quite. They're classes instead of data types. And so there's a little bit of a complication here. First, let's talk about the null storage class. So it represents a null value, means no value or unknown value. It is not the same as 0. It is not the same as empty. It's not the same as false or the text n/a. It is a value that is not present. And that's not really a data type, but it's a value that can be stored in any column. And this seems to violate the rule that a column can have only one data type because it can have its data type plus null. So that's one reason why we call null a storage class rather than a data type. A column of numbers can also have some nulls where we don't have the number. The integer storage class represents an integer value, and it can be stored as usually as an 8-byte signed integer. So if you know what an 8-byte signed integer is, you may know that it can store numbers up to roughly 9 quintillion, 9.2 quintillion, and down to minus 9.2 quintillion. Assigned integer simply means that it has a, plus or minus sign, and 8 bytes means that it can store 2 to the 64th bits, but one of those bits is reserved for the sign. Otherwise, it would be 18 quintillion, by the way. Otherwise, it would be double that because it would multiply it by 2. The real storage class represents a floating point value, so it's stored as an 8-byte floating point number. And IEEE 754 is a standard formulated by the International Electronics Engineers Epsilon. I forget what IEEE stands for, but it's the International Engineering Society. And they set standards for things like numbers, and this is an 8-byte number. So part of this number is the mantissa, and part of it is the exponent, if you know anything about floating point numbers, which you don't need to know about in this class, but this is the most efficient storage class for floating point numbers. Okay, and then a text um, represents a text value, and it is a string of characters. And there can be at most a billion characters in each value. So a billion is the same as the popular definition of gigabyte. So you can store, for example, a movie, like there are lots of Hollywood films that are available in MP4 format that are like less than a billion bytes. So you could store one of those as a single uh, text value. Actually, you wouldn't store it as a text value. You'd store it as a blob value, a binary large object, which is the same has the same limitation on size. What would be a text value of a billion bytes? That would be a lot of books as one text value. Okay, now SQLite does not have, so most databases, most client-server databases have a Boolean storage class. So instead, Boolean values are, which are false and true, those are the actual Boolean values, and they're stored as 0 and 1. And it recognizes the keywords true and false as of 2018. But those keywords are just alternative spellings for the integer literals 1 and 0, respectively. SQLite does not have a separate date type. It has 3 ways of representing dates: text, real, or integer. I personally only use the text and integer. I don't even know what the real, I put down the real format is Julian day numbers. I never use Julian day numbers. But I often use this format, and I often use um, this format. All dates that are stored as dates in a Mac or a Linux computer are stored in this format, the number of seconds since the epoch being midnight on January 1st of 1970. Microsoft uses a similar scheme, but they chose a different date in order to break compatibility and enhance vendor lock-in. So they have a different date than the than the epoch. So SQLite has to be, to some extent, compatible with other SQL databases. So it has these type affinities, and the type affinities are the same, or roughly the same, as the storage classes. And all these type affinities are what SQLite stores when it receives a information in one of many kinds of formats that are available in databases. So let me show you some of those. So for example, for integer, some databases store it as an int, some store it as an integer, some store a tiny int, which is like a maybe a 2-byte integer or something like that. A small int, maybe that's a 4-byte integer. A medium int could be a 6-byte integer, and a big int could be an 8-byte integer. I'm just off the top of my head. An unsigned big int would be even bigger, maybe an unsigned 8-byte integer. Int 2, I don't even know what that is. And int 8, I don't know. Maybe int 2 is 2 bytes and int 8 is 8 bytes or something. The point is that other databases like Oracle or PostgreSQL have all these different classes that you can use to save space if you know for sure that your integers are not going to exceed a certain size. So SQLite doesn't have those, so it will actually assign any of those to its 8-byte integer, um, but the create statement that created them is still compatible with other databases. So you can transport this database into another database management system. Okay, so the first rule for type affinity is as follows. If the declared type contains a string int, the affinity is integer. And all the examples in the preceding frame, all these examples have the string int in them. So the affinity is then integer. And then there are like I don't know, 5 or 6 rules that are in the reading of this week, along with the table of examples. So read up on this type affinity stuff so that you can understand when you go into the workplace and you use a client server database, how that may differ from SQLite. You won't need to use these other types this semester, but they're valuable for you to know about for future use. Okay, and that's all I want to say about entities. And the next thing is going to be data collection. And thank you for your attention, and I hope that you will watch the next video with me.